So we've heard from the companies that will power the 5G networks and devices. Now I'm excited to introduce to you the technical leads of all 4 of our national carriers, and they're going to share their vision for America's 5G leadership. So we're going to start with Sprint with Dr. John Saw. Along with CTIA's chairman, Marcelo, Dr. Saw provides the vision for Sprint's 5G ambitions to leverage Sprint's deep spectrum portfolio and to better serve customers. DC will be one of the first cities to see the new technology from Sprint as it executes on its mobile 5G network stated for launch next year. Welcome, Dr. Saw.
Thank you. Good afternoon, and thank you. In my talk today, I was going to share with you a little bit about what Sprint is doing about 5G, but rather than just tell you how awesome the Sprint technology is, which it is, I'd like to share with you some of the challenges that we're running into and things that I think some of the audience in this room can help us out with. So I think there was a report that came out recently that the Europeans won the race for 2G, and that spurred a big industry in terms of how the infrastructure ecosystem is being developed today. The Japanese won the race to 3G with I-mode, for those of you old enough to remember that. And guess what? I think the United States won the race for 4G. Without winning the race for 4G, you would not have an Uber today, and an impact it has had on our lives. But I think 4G is, we're running out of gas with 4G. If you think about the opportunity for wireless that we need to disrupt other vertical industries. So 5G is not just, people talking on phones. It's actually, you're going to have more machines talking to other machines than actually people talking on phones. You're talking about massive densification, real-time performance from almost every machine and devices, gazillions of them, massive IoT, right? So higher capacity, higher speeds, not just better phones, but higher density, low cost, low power, right? Low latency, ultra reliable communications. So we need to build from the foundations of what we have on LTE, but we need to make it better, and we need to make it denser. And I think you've heard from speakers earlier today that other countries are moving faster than us in a lot of ways of how they build infrastructure. It takes weeks to get a permit in some countries like China, and it takes us years to get a permit to build one small cell, but it takes us an hour to install it. A small cell the size of that can fit in your backpack. So that has to change if we really want to take the lead and continue to take the lead with 5G. If you look at all the stuff that needs to happen, right, this industry is willing to spend $275 billion of our money to invest in 5G. I think that the Essential report says it'll create 3 million jobs. I think that's a low end of the estimate. If you look at all the things that we need to do as an industry, it takes a whole village to build a 5G network, not just Sprint, AT&T, Verizon, or T-Mobile, right? We need a whole country behind us, right? We need spectrum. We need sites. We need access to public infrastructure to put more radios than what you see today to get the density that our devices and our phones will need. We need to look at how we build core networks differently, virtualizing them, moving them to the edge, so that you get real-time responses when you do crazy things like remote surgery, right? We need backhaul. We need to upgrade our fiber infrastructure for our cell sites. We need devices that work real-time with 5G protocols that give us lower latency, higher capacity than ever before. And we need to have deployment, a lot of deployment to build this 5G network. If you look at how we densify a network, there is not enough base stations in this country today to support what we need for 5G. So we need to look beyond just towers and look at other public infrastructure, street furniture, to install more and more 5G radios, small, medium, and big ones. So typically we'll start with a traditional macro, By the way, for all those who work in wireless, this is going to be so boring, but hopefully it's going to help other people. Right? We're going to start with macro towers, right? And this is the basis of our LTE networks. As we densify our network, we need to get our 5G signals closer to our customers, close to machines and locations where they're needed. So you need small cells. The challenges, and as you have heard this morning, and you will hear all day today, the challenges with small cells is that in a lot of jurisdictions and cities, it uses the same processes to approve the permit for a small cell as if they were macro towers. And that takes a really long time. And then you need femtocells, which are indoor units. And in some cases, we even leverage strands that you see between poles to install small cells because they are readily available in some communities. What you see in this picture here is the full densification of what you'll need, not just for Sprint, but for any operator who wants to provide a solid 5G network. Now, talking about Sprint, we are going to play to our strength and leverage the spectrum that we have the most, which is a 2.5 gigahertz band. That's mid-band spectrum. We have enough spectrum that we can actually allocate half the spectrum for LTE and half of 5G simultaneously. We're sitting on enough fresh spectrum that we can now put it to good use for 5G. The turning point was when 3GPP basically specified the 5G non-standalone spec, and N41 or band 41 or the 2.5 gigahertz band is included in that spec. So we took the spec, took it to our manufacturer partners, our OEM partners like Ericsson and Nokia and Samsung, and said, can you build a 5G radio today? And the answer was yes. And so this is how we got started on this journey. So basically what we're going to be leveraging today is basically the sweet spot, I believe, for 5G, where you have enough capacity across LTE and 5G using dual connectivity of 120 megahertz of spectrum simultaneously, right? And leveraging existing cell site using a technology called massive MIMO. We actually have a display out there. It has 128 antenna elements. This is a key 5G enabling technology. You're going to see this even for millimeter waves. We can use it for 2.5 gigahertz because it's high enough in spectrum bands that you can actually squeeze 128 antenna elements into one radio, into one antenna. It's hard to do this in low band spectrum because you'll be the size of a small car, potentially. But for us, with 128 antenna elements, we can actually logically split the antenna elements into half and use half our spectrum on 2.5 for LTE and bring in fresh 2.5 spectrum for 5G simultaneously on the same hardware. So the advantage that we have in terms of a race to 5G is that we are going to be upgrading existing cell sites that has 2.5 gigahertz with massive MIMO. And the antenna, as you can see, is actually slightly smaller than an existing 2.5 gigahertz antenna. What you don't see there is that the present 2.5 gigahertz system actually has radio elements attached to the antenna. It's not shown in this picture here. But with a massive MIMO system, the radio is embedded with the antenna. Now, here's the challenge that I still scratch my head with. When we looked at this, and I asked the deployment team, if we're going to an existing cell site and we're upgrading the antenna to something that actually looks smaller and more compact because you don't need any more radios around it, wouldn't it be faster to deploy this network? The answer is no, not really, because it's the same process we've used all along. Now, why is it this way? Well, that's because this is how we've always done it. If we are serious that we want to win this race to 5G, we need to seriously look at how we get permits approved faster with a predictable process at reasonable cost to get these antennas moving faster so that we can deploy them fast. This is just another block diagram that shows our evolution of what I just talked about. We start with a massive MIMO antenna, and we're starting to build them starting this year. By 2019, we're going to have software available for 5G, and on the same hardware platform, we're going to enable both LTE and 5G in what we call a split mode. And with split mode, will support LTE and 5G simultaneously with dual connectivity to our new phones. And we can then use dedicated spectrum for LTE and 5G, basically to launch a 5G network that has the same coverage as our LTE network today, which is quite different from some other operators are doing it, where their 5G and 4G coverage may not be the same because they're using different spectrum bands. So in short, what do we need to win a global race for 5G? In the last 2 years, Sprint has spent more than $20 million paying for historical review fees for every small cell. We pay an average of $8,000 per pole, per new pole, for historical reviews. Interestingly, when a wireline company or a power utility company builds on the same pole, they pay nothing. So we were extremely excited and happy that the FCC has recently put in basically reformed the whole historical and environmental processes so that this process is now more streamlined. So that was greatly welcome. We believe that we need also streamlined and predictable process to build wireless sites on public structures. We urge the FCC to continue working on streamlining the access to federal lands. Right now, that is the solution of last resort for many operators because it is just so cumbersome, whereas that should be the first priority to get access to federal infrastructure. We would like the FCC to release more spectrum. While Sprint has a lot of spectrum in a mid-band at 2.5 gigahertz, we are very open to actually looking at deploying millimeter wave spectrum as well if we have access to it, so that we'll provide a good complement in areas where we need even more capacity than 2.5 gigahertz can offer. And we are excited that the FCC has recently announced the auction for the millimeter wave spectrum end of this year. And lastly, we do need to do something about fees. We could use everybody's help to reduce the fees required for small cells. Right now, some cities are looking at what they call market-based pricing to site a small cell. We believe that a more rational economic model is probably better suited for us to win the race to 5G, where carriers are not being charged a premium, but we pay basically just the direct cost to actually install an infrastructure on the public rights of ways. And in this way, we can direct the resources and our capital spends to building even more sites. Thank you.